Hello, Earth Science students. Hey, thank you very much for opening this up and continuing on our quest to learn the information needed for Chapter 27, studying the Earth, Moon, Sun uh, relationship, for lack of a better term. Got some exciting stuff for today. We are going to be looking at the moon, some of the features, properties, history, just some great fun stuff. I mean, if you hopefully you enjoy uh, things and topics that we're going to talk about today, and certainly uh, the whole SpaceX thing that's going on right now, and the International Space Station, and if you're a fan of the Big Bang Theory, down through the years, a lot of talk about this kind of stuff with Wolowitz and his astronaut experience and all that good stuff. Even though it's a fictional story, you get a lot of insights. And if you watched, one of the cool things about watching the SpaceX broadcast, especially the first time when the mission failed, is a couple of characters, a couple of people that were featured on Big Bang Theory, Maz and stuff. I mean, they were on there just to let you know that those were real life scientists they were using. They weren't just actors playing parts, but they were actually people involved in the NASA program. But that's pretty cool kind of stuff. So a lot of stuff, and as always, hey, be sure you take the time to do this proper. That you get the things written down that you're supposed to, and have this done by Monday, so we can get you the points needed for doing your homework assignment. And again, homework is always air quotes. So, but again, I will always kind of showcase uh, what's what to record, what to write down. But if it's written down on the screen, as you can see, a couple of things there already, you should certainly write that down. But I'll always mention and point out things to write down. And of course, hopefully, you still have your pictures. Uh, the pictures that you see, I would have given you, so you can label those as well. And the paper that I gave you, you can write down everything on that. Not a big deal, and give that back to me on Monday. So, but again, welcome. Thank you for watching this. Thank you for being part of your educational journey. And so, with that, let's get started. This is designed to be an hour long, but that also includes the time you need to write things down. So, as always, as you're watching this, something you need to write down, feel free to pause, write it down, and restart it when you're ready. You don't have to do it in real time or as I'm talking. And as always, you got you're at home, you're wherever you are watching this. Who knows? Maybe you're at work on lunch, or I don't know. But you've got to, but take advantage of the benefit of being able to pause it, do what you got to do. You get bored, go do something else, come back to it. Just make sure you have it done. But again, as I started to say, this is supposed to be an hour long process. So hopefully I can keep the video 30 minutes, 35, 40 minutes, and then you writing down the notes will be a majority of the rest of the time. So with that, hey, let's get started. And we're going to start off with a little history. So I'm just going to pull this over and kind of blow it up a little bit so we can really see and showcase what's going on. But you have a paper, hopefully you have the paper, and it should have this picture of the timeline. And what's above here, let me get a pen here. See, we're going to the moon. What would be a good moon color? Let's see what's in here. What would be a good moon color? Highlands are light, mirrors are dark. Let's just go with orange. I don't know what a good moon color would be. So, there we go. Let's get a little bit bigger. What's that look like? That may be too big for writing. So we'll go with this one right here. Let's test it out. It should be decent. All right, but you should have this picture right here on your paper, and you're going to be writing down this information. And I'll put a big old square around it here, kind of a square. All right, so let's get started. Some history of timeline of space travel, and you gotta remember the era that we are talking about. We're talking middle of last century, so 70 years ago. So think about 70 years. I mean, let's see, this is 2020, so I'm 54. So I wasn't around for most of this. Let's see, if we look at years, I would have shown up kind of, let's see, that's 75, that's 50. So this is approximately 60. So I'm kind of like right in here as far as being born. So that tells you how old I am. So to truly been around for all this and to really understand what was going on, you probably got to be 80-ish. So think about, grandparents, great grandparents, that kind of stuff. So if you're 16, your parents are probably in the 35, 36, 38 range. So their parents, your great grandparents, are going to be, basically my age. Um, so it would be great, great, great grandparents that maybe have a shot at remembering these. But hopefully, you've got someone in your life that you could talk about or ask about some of this stuff. And but anyway, let's get let's get to it. Our first one right here, the first rocket, and that's uh, referenced right here. The first rocket launch, 1942. Uh, Russians launched it up in space just to get something up off the ground and out there in space. Okay, then it was a full 15 years later before a successful launch, and now we're here. Number two, which is referenced down here. Number two, Sputnik 1, Russian spaceship out into outer space. Put a dog on there just to get some semblance of a living organism could survive the travel. Of course, with all the regulations today, I don't think you get away with doing that today as an experiment. But 1957, okay, then 4 years later, and now we're here, number three, which is also right here, number three, the actual first person up in space, a Russian astronaut, Yuri Gagarin, I guess that's how you pronounce it, traveled up in a rocket and then back down. Uh, okay, then the same year, it's not on our timeline, but we're right here. USA, we sent up a rocket with a person in it later that same year for the second person to be up in outer space. And then, our NASA program kind of took over the lead. The Russians got there first, um, but with our resources uh, and everything, we kind of took the lead after that. From 1965 to 1966, we put the number 10. This isn't note 10, but during those 2 years, excuse me, we launched 10 rockets in the Gemini, Project Gemini series with a variety of 2 to 3 man crews. What we were really trying to do was to progress further and further each time. And what we were building towards was the infamous trip to the moon that everybody wanted to get to. Now, the Russians were trying to get there. We were trying to get to. We wanted to be first, and it was all part of that competition between the two countries. Uh, if you know anything about about the history time, back in the 60s and 70s and 80s, there was a real power struggle going on between the United States and Russia to be who was the best in sports, whatever the field was. Excuse me. But your social studies teachers can tell you a lot more about that than I could. But anyway, in 1965 through 66, we sent 10 uh, Project Gemini rockets up with crews building towards getting to the moon. And finally, in 1969, the famous trip, uh, which produced the famous phrase, one small step for man, one small step for, so one small step for man, for mankind. Anyway, whatever it is, I can't even think of it right now. That Neil Armstrong mentioned. Excuse me. Anyway, got him to the moon, 1969. That's referenced. Uh, the next note here, we'll put a 4 here and a 4 down here. But we got there, 1969. And then since that time, we've done lots of things to get more information about the moon. We've launched space probes in 94 and 98. These are basically probes that are just traveling around the moon, taking pictures, gathering information, that kind of stuff, ongoing. And of course, having the International Space Station out there, part of the way, Hubble telescope, all those things, all those other telescopes that are out there giving us information. And now we just have a plethora of information and photographs and images and satellite information about the moon. There's almost nothing that we don't know about it or can't conject about it. And you'll hear a bunch of that today. Even the internal structures of the moon, we think we have a real good idea of what it is. May not be right, may be correct, may not be correct, but anyway, but a lot of that stuff we will go over today. So certainly one of the things that you do want to have written down is this historical information, this kind of timeline information. So need to pause. If not, we will continue. Let me close this ink tray. Let me slide down here and begin to talk about some of the things of the moon. Okay, obviously this is the picture of the moon. This is the picture of the moon over here. Got pictures of the surface of the moon here and down here. And we're going to talk about all the different aspects of it. So let me pull my pen back up. Okay, so here's the next thing that we're going to talk about and what we're going to try to do, which means I need to slide this over just a little bit so we can get this picture in here as well. And down. Excuse me. So we're going to use these 4 pictures to highlight these vocab words. Now, one of the things we want to talk about, and we'll really identify it when we don't have an ink tray yet. We will really identify it when we talk about these pictures down here. But one of the things we want to recognize is that when you look at the moon, you always see the same side of it, okay? Which would insinuate that it doesn't turn. But that's not the case. It rotates just like we rotate on our axis. The situation that's going on there is that the rotation time, like our day when we go around our axis one time, that's considered a day. The moon rotation is almost identical in its rotation. So we're basically turning at the same time, so they're at the same speed. So therefore we always see the same side. That's why you have the infamous phrase "Far Side of the Moon," which is a great song and album by Pink Floyd, but that's probably not your musical style. But if it is, fantastic. So the idea when we look at the moon, we generally see this picture right here at all times. I guess it's ended up being a cool color to use because with the black pictures and the orange, Halloween, moon, all that kind of good stuff. So accidentally got a good tie in there. But we always kind of see this same image. Now, the first two things we want to highlight is the highlands and the Marias. Okay, the highlands, excuse me, is kind of this area in here, but it's that light color that you see in that distance. That light color, those are the mountainous areas. Okay, those are also the areas that have been heavily cratered, and but we say that, but in the early days of the moon, and again, we're not going to get into years. If you, based on your family personal beliefs or history, you may think that the Earth is fairly recent, a couple thousand years old, life and everything. You may think it's the billions like scientists do. You may not have it care either way. So we won't worry about years, just processes. So we say that the highlands are heavily cratered. The Marias obviously would have been hit as well, but their craters have basically been covered up, and we're going to talk about that here in just a few minutes. But the highlands area, light in color, lots of mountains, lots of crater holes from being hit by meteors and just things, just debris out there, and um, in the outer space. So the light part, that's the highlands. The darker areas, this kind of stuff in here, that's the Marias. Over it, that's the plural. If it's individual ones, you're talking about, then it'd just be mare, as you can see there. If we talk about all of them, they're called Marias, and they're dark in color, and they are flat ground plains. You might use that term as well, but there's a reason why they're flat. There's a reason why they're dark. The reason why they're plains. That's because we believe that the mountains on the moon, okay, used to be have volcanic activity, and we're going to talk about the surfaces once we get over there to properties. But volcanoes in the mountains, and as they put out their lava, okay, which creates the color difference, and I'll identify that and we'll write this down here in a little bit. Um, that lava is from the internal part of the moon, and it's a different rock surface, different type of mineral than what's on the outer edge of the moon. So basically, what was inside the moon spilled out as lava onto the surface, and it's a darker color mineral. So therefore, it makes that darker, but it also would have covered up or filled in the all the impact craters in that area. So it looks like it doesn't have craters, and you can't see them. They would have been there at one point in time. Okay, so that's the light and dark areas. Now, some other things. Obviously, let's talk about things like this and things like this. And if we go over here to this other picture, better examples, things like this, things like this. These are obviously impact craters, holes, and you can see that the rock area is kind of lighter in color. So we're talking about the highlands. But these impact craters, some vocab words associated with those, ejecta, and I'm right here, ejecta. That's minerals or materials that kind of uh, spits out or blows out when these meteors hit the surface of the moon. If you can imagine the meteor hits the surface, and it kind of, all that rock area that was there, rock stuff that was there, gets thrown up into the air or splattered out. And you can see those, that's called ejecta, and you can see that, like this stuff, like right in here, this would be ejecta. All this stuff kind of right in here, this would be ejecta. Things that have been displaced, they've usually just kind of formed the walls or the edges of these impact craters. But that's ejecta, material that's been thrown out of a spot where a meteor hit the surface of the moon. Okay, now rays, okay, rays are long trails of ejecta. So stuff possibly like this stuff right in here, okay, these piles, impact crater, and the stuff goes up and it lands and can make these big piles or long trails. You can imagine it kind of just is thrown a certain distance, making a little trail. The bigger, looser stuff, and then the heavier stuff may be closer, so it kind of makes these trails. But those are rays; those are called rays. And then the riles, if you can imagine stuff like this, it looks like it's sunk in. And here's some more over here. Those are possible, what we believe, maybe collapsed lava tubes, but they're kind of just valley-like structures. But anyway, we're just throwing out the idea of maybe those are lava tubes inside the earth that are starting to collapse down onto themselves, and therefore making those grooves in the surface. Okay, regolith is our last vocab term, and this is just simply layers of loose ground up rock, uh, possibly ejecta as well, but it's just kind of ground up rock that's been broken free and just kind of laying there loose. So that's our vocab words. So be sure that you write that stuff down. Okay, our next topic. Let me close my ink tray and slide over here a little bit. Talk about the properties of the moon. Let me go over here a little bit further. Get my pen back. So now we're here. Properties of the moon. Okay, some things to write down. It's one of the largest moons of all the moons that are out there. It's one of the largest. It's obviously made of rock, similar to what we are, solid rocky body. And of the moons that are out there around any planet, It's the farthest from the planet that it's going around, that it's rotating around, orbiting around is a better word. And it's made up of silicates. Now you'll write that down, and we will talk about it in class. One of the things that we will emphasize and reinforce to learn, but that'll make more sense once we get to rocks. But silicates, let me come over here. Silicates are rocks. Let me change. Yeah, that'd be better. Silicon. That's supposed to be a C. And oxygen. And yes, looks like a lower elementary school handwriting, but writing with the mouse. So what are you going to do? G here. So silicates are rocks or minerals that are formed from the bond between silicon and oxygen. So they're called silicates. If you've had a chemistry class, the SiLi, that refers to silicon. And anytime you see that word cates, that means oxygen. It's something bonded with oxygen. So that's the idea of properties of the moon. Now, going back to the idea of the different colors. Okay, so I'm going to draw me a line all the way over to here. Okay, the surface of the moon, or the highlands, that's made up of feldspar. And when we get in class, and hopefully, and even possibly have already shown you examples of feldspar, so you can have a mental idea, but you can also Google it. Feldspar, these minerals are very light in color, whitish, pinkish, light pink, something like that. Okay. And the Maria area, that's basalt. Okay, and hopefully we've already seen that in class, but that they're dark. Okay, these minerals are dark. So when that lava come up out of the mountains, okay, it's made of basalt, very dark, and so the lava pours out onto the surface of the moon, cools, and gives a very flat look to the moon, covers up the impact craters, and of course it's made of basalt, so it's much darker. So that's what generates that or creates that difference in color between the various surfaces areas of the moon. Okay, so let's see the next part. Let me close this ink tray, and of course, again, be sure that all this stuff is labeled, written down. So let me close out my ink tray. Let me go smaller here so I can see everything. Yeah, so our last two things to talk about are these two bottom pictures here. So let me rotate that. Go back up to 62%. Slide this over more here. Bring up my pen again. All right, so you know what? We need to be bigger so we can see this image right here. Now I know it's kind of fuzzy, but hopefully the pictures on your paper are clear to where you can truly read the information. We're going to talk next about this section right here, and we're going to compare the internal surface of the Earth and compare it to the internal surface of the moon. So if we start at the very, very edge, you can see that both the moon and Earth have a crust, and that would make sense. That's the surface that you see. Okay, that's going to be, in our case, we always have water as part of our uh, surface, but the crust, we're talking about that mineral, that stuff underneath on the plates. Okay, now the moon has a mantle, and Earth does too, except we have an upper and lower mantle. And the reason why they're separated by name is because the composition is different. The lower mantle is a little more solid and a little bit different, and you can see the difference in color here. Whereas on the Earth, on the moon, I should say, it's all the same color. Now, both the moon and the Earth have a core with both an inner and outer core section. And of course, the inner core is going to be under extreme pressure, and so it's got that solid iron core middle, but the outer edges, there's a little bit of partial melt, and that's what separates the inner and outer core. So, a lot of similarities, okay, a lot of differences. So, what you would want to do on your paper, be sure that you would label or list. Let me just write this on here. List the similarities and differences. Oh, I didn't mean to do a B there, so let's try that again. Differences. So I'm just going to do sims and diffs. Oh boy, that F went bad. There's supposed to be an I in there somewhere. So be sure you list those similarities and differences between the two. Not going to be a long list of either one, but make sure you recognize what you've got there. So for our last thing, we're now going to talk about this picture right here. And again, you should have this on your paper. Now, as a way of reviewing, we talked about why there is a color difference between the Maries and the Highlands. We talked about why you can see a lot more craters in the Highlands than you do the Maries. But as I mentioned, you do see some craters in there. And what that tells you is that that meteor strike occurred after, the volcanic activity would have occurred since it's on the surface of it. Okay, we also talked about why the different colors, the different minerals that are involved, and things like that, the structure of each of the two mountains, plain flats. Okay, but what we want to compare it to is the far side of the moon. Okay, you don't see this dark color, which would insinuate now the far side doesn't have the mountains that the near side does. Okay, so it's going to have a lot more of the impact craters. But this is a part that we can see it through images and photographs, but we don't ever actually get to see it visually from Earth with our naked eyes because we're always on the opposite side of it. So again, you're going to want to list the similarities and differences between the internal structures, and you're also going to want to list the similarities and differences between the near side and the far side as part of your notes. And you can do that just visually here, the different colors, the impact craters, that kind of stuff. And again, it won't be a long list of either one. Just make sure that you take the time to do that, please. All right, so with that, we will end this video. Again, thank you for participating. Thank you for joining in. And just as a review, let's go all the way out here. Close the ink tray here, bring this down. Now I need to go further out and over and down. Yeah, now we can see everything. So when it comes to what I'm gonna be looking for on the next time we come together, certainly this timeline notes, the labeling of the materials, the labeling, the rays, the ejecta, the riles, the regolith, that kind of stuff. The comparisons between the internal structures of the Earth and Moon and the comparison of the surface stuff between the near side and the far side, as well as these two boxes right here. So quite a bit of stuff to check off on. And again, the grade that you get for doing this homework assignment is simply going to be, here's my list of things I'm looking for, looking at what you have, and basically a percentage of that. So the points given towards it, if you have everything, then you'll get the full points. If you have half, you'll get 50%. If you got 3/4 of it, you'll get 75%, etc., etc., etc. So with that, we'll start to say goodbye, or I should say we will say goodbye until next time. And again, thank you. Look forward to seeing you in class. Hopefully everything's going well with you. You're safe. Your family is safe. Everything is hunky-dory. Until next time, we will say goodbye.